Okay, let's talk about the lung mechanics, a very important concept. The movement of lung is passive and determined by the impedance of the respiratory system. What does that mean? When the air is entered through the airways to the alveoli and to the lung, it will face two types of resistance. The first one is the dynamic resistance, the airway resistance, the resistance that happens as a result of friction between the gas entering and the airway. This is the dynamic resistance. And why do we call it the dynamic resistance? Because it is a result of a flow through the airway, the movement of air through the airway. Once the gas is into the lung, in the alveoli, it will face a second type of resistance, which is an elastic resistance of the lung. The lung has a tendency to collapse due to the elastin tissue in it. Okay, so the more the elasticity in the lung, the more the tendency to collapse, the more the resistance it faces the gases when they enter the lung. Okay, so this is the second type, which is a static resistance. So the dynamic resistance is the flow. Resistance happens when the gas flow through the airways. The static resistance is the resistance in the lung tissue due to the elasticity of the lung, and not only the elasticity but also the surface tension. As you can see here, the large alveoli and small alveoli. This small alveoli has a tendency to collapse, okay? And the tendency to collapse is caused by the surface tension, And to overcome this surface tension, we have a special type of polysaccharides in the wall of the alveoli, which is the surfactant. The surfactant will overcome the surface tension and prevent the alveoli to collapse. As you can see here, the small alveoli, السرفاكتنت فيها بيكونوا very concentrated and the surface tension is high, but because of the concentration, the high concentration of surfactant in the wall of the alveoli, it will not be collapsed. هلا بس تكبر الالفيولاي when it gets larger due to the inflation with air, the surfactant concentration will decrease, صح؟ والsurface tension كمان will decrease. عشان هيك small alveoli عندهم tendency انهم ما يصيروا smaller، لانه ايش؟ السرفاكتنت بيكونوا كثير concentrated وبيمنعوا انها تسكر وتصير smaller. And the larger alveoli السرفاكتنت فيها بيكونوا less concentrated and it has less tendency to become bigger. Okay, just like a bubble. We have the Laplace law. The Laplace law says that the pressure in the alveoli, okay, is directly proportional to the surface tension times 2 and inversely proportional to the radius. So the pressure of the alveoli will decrease if the radius increase. وكمان السرفاكتنت concentration برضو راح تقل. With the radius قل, if the radius decreases, the pressure in the alveoli will increase, but the surfactant concentration will also increase, and this is what we mentioned before. Okay, so now let's move to another concept, which is the compliance of the lung. Now let's say expansion of the lung, okay, with volume or with the pressure, the change in volume of the lung with change in pressure depends on the previously mentioned what? Elasticity of the lung or resistance of the lung. So if we have a lung with great compliance, a little elasticity, okay, a little resistance, the volume of the lung will change extensively with a small decrease in pressure. If you apply a small pressure, if you inflate this balloon with small pressure, the volume will change in a great manner, okay, and this is due to a great compliance of the lung. Okay, so the more the change in volume with less change in pressure is a great compliance. So if the volume increase exponentially, okay, with very little change in transpulmonary pressure, the compliance is great. So the compliance is the change in volume, okay, على change in pressure. If the change in volume is great with a little bit change in pressure, then we have a very good compliance, Normally the lung compliance is 150 to 200 ml per centimeter water, okay, 150 to 200 ml centimeter water. And the compliance decreases with restrictive lung disease because the elastin in this case is very little. With intra-abdominal mass, with obesity, okay, the lung will be obtunded or prevented from being inflated, or change in volume will be very little with great change in pressure. So patients with decreased compliance will need very high pressure to accommodate a very low change in volume. So the change in volume with change in pressure is the compliance of the lung. If your lung is empty, okay, and you try to inflate it, at the beginning you will have a great change in volume with a little change in pressure, as you can see from this slope here. But if your lung is already inflated, like for example the upper zones of the lung where they are already inflated with air, the compliance of lung will be little, and that means that you need a great change in pressure to only have a minimal change in volume. We have lung compliance and we have chest wall compliance, which is about 200 cc or ml per centimeter water. The chest wall tendency is toward expanding and the lung natural tendency is toward collapsing. The compliance of chest wall is 200. The compliance of the lung is 150 to 200 ml per centimeter water. And the total chest compliance is the sum of 1 over the chest wall compliance plus 1 over the lung compliance. Very important concept to understand and very easy. So you have to remember the surface tension forces, the Laplace law, okay, and the concept of lung compliance. Thank you very much.